Hello again. Today we're going to be starting a new unit on polar equations and the calculus that's associated with them, but for today I'm just going to introduce you to polar equations in general. So first let's contrast polar coordinates with what we've always used as rectangular coordinates. Normally, to get to a point on the rectangular xy plane, what you would do is you would go to the right, which would be considered positive, or to the left, which would be negative, by whatever the x coordinate is. And then we would go up, which is positive, or down, which is negative, by whatever the y coordinate is. So now, when we're dealing with polar coordinates, we have to change our grid a little bit, as you can see there on the graph. And what we do first is we go clockwise or counterclockwise. Counterclockwise would be positive, clockwise would be negative, by whatever the theta coordinate is. That's going to be our angle. And then we simply go straight out, either forward, which would be positive, or backward, which would be negative, by whatever the r coordinate is. So we've got two coordinates now, which are r and theta instead of x and y. So we need to be able to convert between these two forms, rectangular and polar. So let's look at the formulas that I know based on the diagram that I have on the right. I know that the cosine of theta is x over r, the sine of theta is y over r, and the tangent of theta is y over x. And I also know that because it's a right triangle, r squared is going to equal x squared plus y squared. So how do I use those to convert between x and y and r and theta? Well, if I multiply this first equation by r, I get that x equals r times the cosine of theta. And if I multiply the second equation by r, I get that y equals r times the sine of theta. So there I have x and y expressed in terms of r and theta. Looking at the bottom two, if I take the inverse tangent of that first equation, I get that theta is the inverse tangent of y over x. And if I square root both sides of that last equation, I get that r equals the square root of x squared plus y squared. So there I have two equations of r and theta expressed in terms of x and y. So these first two equations I'm going to use to convert anything that's already in r and theta to something that's in x and y. So from polar to rectangular. And then the last two I will use to convert anything that's in x and y to anything that's in r and theta. So from rectangular to polar coordinates. All right, so when we're graphing these, remember I have to use that new special grid there. So what I have to do is, let's say I'm graphing r equals 2 times the sine of theta. First, I'm going to make a table. Theta is my independent variable and r is my dependent variable. So I plug in a bunch of random values of theta and I calculate the r value for each of those thetas, and I get that table right there. And so I graph each point separately, just like I would if I had a table of x's and y's. So when I'm graphing 0 and 0, I turn to 0 radians and I go out 0 spaces. So I'm right there at the origin. Then for the next point, I will turn pi over 6 radians and I will go 1 space directly out from the origin. And there's that second red dot. Then I turn to pi over 4 radians and go out 1.414 spaces and put a dot. And I keep going, pi over 3 to 1.7. Then turn pi over 2 and go out 2 spaces, 2 pi over 3, and again go out 1.7 spaces, 3 pi over 4, and then go out about 1.4 spaces, 5 pi over 6, and go out exactly 1 space, and then at theta equals pi, I will go out 0 spaces, and that gets me back to where I started. So I've graphed all the points in the table, so I just join the points in order with a curve, and as you can see, that curve forms a circle. All right, so how do I convert equations instead of just coordinates? Well, I still need to remember those 4 equations that I used to convert. Those were on that previous slide. So if I wanted this to be the equation of a circle in terms of x and y, here's what I would do. I would start with the equation I was given, and then I noticed that if I multiply both sides times r, then I get r squared on the left, and I get 2r sine theta on the right. Well, how does that help me? Well, one of the equations that I wrote before said that r squared was x squared plus y squared, and another one said that r times the sine of theta was y. So I can make those substitutions, and the left side becomes x squared plus y squared, and the right side becomes 2y. So now I have an equation that is purely in terms of x and y. And then if I solve it by subtracting 2y from both sides adding 1 to both sides, and then rewriting the left side so that it is x squared plus y minus 1 all squared equals 1. That's the equation of a circle that I'm used to. And so you can see that the center of the circle is going to be 0 and 1, and the radius is going to be 1. So this is a circle with center 0, 1, and radius 1. If I put that old XY grid back on there, you can see that the center is at 0, 1, and the radius of that circle is 1. So that's just a brief introduction of polar coordinates and polar equations. If you have any questions, please let me know, and I will see you tomorrow.